Okay, coming to the last type category of the reaction, we have done the first as an acid reaction, the second one as displacement reaction, and now coming to the third category, that's a precipitation reaction. So precipitation reactions are those reactions where a solid product is being formed, and that because a solid product is being formed, we call them precipitation reaction because they appear as a precipitate which remain insoluble in the reaction mixture. All right. Now there are two aspects to it, and these precipitation reactions they are of utmost importance for us. Now, on the basis of the precipitate which is being formed, we can identify, we can perform, we can use them as the chemical test. So, looking at the precipitate, the color formation of the precipitate, we can identify okay, this particular ion is being formed, this particular compound is being formed, and it is also used for to work out the chemical equation. So, these are the two applications of the precipitation reaction. Okay, this is how we use the precipitate reaction. Number one for the chemical test, and number two to work out the chemical equation. Let's see how is it so one by one. Now, when we talk about that they can be used as a chemical test, so first of all, it comes to our mind, or we can say that we can do the identification test for carbon dioxide. Now, calcium hydroxide is generally known as lime water. So, whatever the carbon dioxide, if any test is giving you carbon dioxide, and we have to check the presence of the carbon dioxide, that the carbon dioxide is a gas which has been liberated, we will be going for the precipitate reaction. So what do we do is that whatever the test is producing the carbon dioxide, now through the delivery tube, we will be passing the gas into the lime water. Okay, so lime water is basically calcium hydroxide, will ensure that this gas is passed through the lime water, and lime water is a general name for calcium hydroxide. So when we'll be passing the gas through the lime water will be giving, the lime water is calcium hydroxide. So when carbon dioxide will react with this, we'll be getting calcium carbonate, and calcium carbonate is a solid compound, so it will precipitate out. We can see its solid state symbol. So it is this particular when a substance we get as a product as a solid, we call it precipitate. So the precipitate of calcium carbonate will make the lime water look chalky or milky white. It'll goes chalky or it'll go milky white. So when this happens, when any gas when passed through lime water, and this is the appearance, this is the observation we notice, we know that the gas is carbon dioxide. So that is the reason we say that the precipitation reaction is used or is employed for the identification of a gas, especially the carbon dioxide gas. So that is how we can use the precipitate reaction. Similarly, there's another example where the other ions can also be identified. Now, for example, if we have a sodium sulfate and barium chloride react together, so we will again get a white color precipitate being formed. These both are aqueous solution. When I'm adding aqueous solution, we get a white precipitate or white solid appears. Okay, so this is an indication white solid appear, right? This is an indication that we have a barium sulfate. So this is an identification of sulfate. If on addition of barium sulfate and barium chloride, we get a white PPT that is of barium sulfate because a double displacement reaction took place. Double displacement reactions are those reactions, this is new for you people, Double displacement reactions are those reactions where the cation and anion of the two reactants switches their position. That means the barium it combined with the chloride, whereas the sodium it combined with the chloride, and the barium it combines with the sulfate. So they switch their positions, and therefore a barium sulfate will be formed. And barium sulfate we know out of three sulfate which is in our course, which are basically solid. One of them is barium sulfate, another one is calcium sulfate, and next one is going to be your lead sulfate. So we know that these three sulfates are actually going to be solid. Now, because we added barium chloride, so that we are aware that the barium sulfate will be formed, and that is also an ionification test for sulfate. Okay, and this is going to be the precipitate ionic equation for this precipitation reaction. This is an ionic equation we can form like we have been doing step by step, that we write down the balanced equation. After writing down the balanced equation, we write the state symbols. The aqueous we split up into ions and then cancel out the commons, and the remaining is ionic equation. Try the same steps, you will get this as a ionic equation. Now, for the precipitate reaction, there's a shortcut of writing the ionic equation as well. For example, if you're getting a barium sulfate as a solid product, so what, as an ionic equation, we can just do it that whatever the barium sulfate is made up of, we'll write down the barium ions in the aqueous state, and we'll write down the sulfate ion in the aqueous state. That is going to be my ionic equation for the this precipitation reaction. We can use the same thing for any other insoluble salt form. If there is a precipitation reaction where silver chloride as a solid is being formed, and the examiner asks us to write down the ionic equation. So we know that the silver chloride is formed of Ag ions, which will be coming from the aqueous salt solution, and silver chloride is made up of chloride ion, which again is coming from an aqueous salt solution. So this is what actually going to be our ionic equation, where a silver chloride as a precipitate or as an insoluble salt will be formed. The same will be for any other insoluble salt or any other precipitate. If the examiner asks us, so we will just split it up into ions, and those ions will be in the aqueous solution, because as a reactant we'll be taking their soluble salts. So sulfate will again come from the soluble salt aqueous solution. So this is going to be your ionic equation for the formation of barium sulfate. So this is a shortcut method to write down the ionic equation for a precipitate reaction. Okay. Now after this, they're again saying if we need to test for a halide means the halogen ions. They can be chloride or bromide or iodide. Then again, we will be taking any of the nitrate. We know all the nitrates are soluble. So we have lead nitrate as a reactant, soluble reactant. We have a potassium or sodium halide as again as a soluble reactant. When the two soluble reactants, they undergo a displacement reaction, when they will be undergoing a displacement reaction, so what will happen there? Double displacement reaction. So their reactants, the cation and anion, they'll be switch positions. So lead will combine with an iodide, and the potassium is going to combine with the nitrate. So the lead iodide or lead all the halides, lead halide means lead iodide or lead chloride or lead bromide, all the halides of lead are basically, they all are insoluble. So here are insoluble, or the solid component or the solid product is being formed along with the soluble nitrates. All the nitrates are soluble. So this is again an ionification test. So if a halide is present, so we ensure that we make it in order to confirm the presence of halide. We go for double displacement reaction, where we take one salt which is a halide and another salt which is a nitrate. So what will happen? The double displacement reaction will take place. They will switch positions, and if we have a lead nitrate or silver nitrate, we'll be having lead halide or the silver halide, which are actually insoluble. That is how we can confirm the presence of halide.